right, as we finish up Chapter 1, Section 6, we're talking about the existence of an inverse function. To have an inverse function, a function must be 1 to 1, which means no two elements in the domain of f correspond to the same element in the range of f. A function f is 1 to 1 if, for a and b in its domain, f of a is equal to f and b implies that a equals b. So, the existence of an inverse function, a function f has an inverse function, f to the negative first, if and only if. This does not mean your math teacher doesn't know how to spell. That actually means if and only if f is 1 to 1. Now, you have used the horizontal line test, the vertical line test before, correct? Let's just review. We've looked at the vertical line test, and we know that we use a vertical line if something is a function. If I put a vertical line anywhere on this parabola, it is only going to hit one place. So the vertical line test tells us that something is a function. The horizontal line test is a different test. And the horizontal line test tells us whether or not a function has an inverse. So let's just look at an example of this. If I graph a sideways parabola, and if I use the horizontal line test, it is going to work. It only touches one place. But if I look over here on the left at this parabola, if I use a horizontal line test, it is going to fail because it is going to touch two places. So I know that a parabola does not have an inverse. Now, we can find, using the little tricks that I gave you, change the x and y, solve for y, we can find the inverse of this. But remember what happens if I have an x squared. If I have x squared equals y and I'm to solve, change them around, y squared equals x. And if I'm to solve this, remember when I take the square root, this square root is not an inverse because remember we're missing this whole bottom part of the parabola. So because a square turns into square root, we know it does not have an inverse. If you would like to read more about this, you can look on page 65 in your book. Again, we use the Larson book, Pre-Calculus with Limits, Graphing Approach. And if you'd like to look at that, that is totally fine. All right, so moving on. Example 6 says, use the graph of the function. So this is graphed here. F of x is equal to 3 minus x all over 2. So this is just a linear function. And it says to use the horizontal line test to determine if it has an inverse. So notice because it only hits one place, we know that f passes the horizontal line test. Okay, and then I put it to the test. We've already done example 7. We did that above. But what about example 8? Let's talk about the parent function of this. I know it's a square root function, so I know what the parent function looks like. This plus 1 right here tells me it's going to go up, down, left, or right 1. It's going to go up 1. And it is going to look like this. If I use the horizontal line test, some people start to question because it does go really steep here. It actually continues to build and climb and go higher on the y. But because it's so steep, a lot of people are like, wait, is that? This one does have an inverse. So we determine that yes, this function will have an inverse. All right, last one we're going to look at today is example 10. Example 9 has all my work in it, so I'm not going to show that. It says find the inverse function of f of x equals the cubed root of 10 plus x and use a graphing utility to graph them both. So the first thing we're going to do is switch the x and the y. Remember, we just call this f of x, y. So I'm going to call that x now, and I'm going to put in a y right here. Our first step in solving, we will cube each side. What I do to one side, I do to the other. So we have x cubed is equal to 10 plus y. And when I solve for y, y is equal to x cubed minus 10, because I'm just going to get rid of that 10. Now it tells you to go ahead and put it in your TI-84, so I'm going to give you a chance to do that. Put it in your graphing calculator. I want you to look at the original graph given, the original graph here, and the new one that I just solved for you, the inverse, and tell me if it looks like it's reflecting over that graph y equals x. Great job today.